All right, folks, this video is about atoms, elements, molecules, and compounds. So if you think back to what matter is, it's anything that takes up space and occupies volume. We could consider atoms, elements, molecules, compounds, and mixtures all types of matter. Think back to the atom. Remember that it's got protons, neutrons, electrons. It's the single smallest particle that you can divide an element into and still have that element. Remember, it's the number of protons that determines what element it is. But the important thing is that's the smallest bit that you can take that substance to and still be that element. So there are three basic types of matter we could think of. There's the element, the compound, and the mixture. The element is just any time we have one or more atoms of an element that are combined together. So it could just be one atom, or it could be two or three atoms of one particular element that have a bond between them and they're stuck together. For a compound, that's anytime we have two or more different elements that are chemically combined. So like H2O, there's hydrogen, there's oxygen, that makes a compound. Elements and compounds are considered pure substances if they're all by themselves. And then we have mixtures, which is anytime you mix some things together. It could be different elements, it could be the different types of molecules, it could be anything, as long as they're not stuck together with chemical bonds. Now there's an example of an element. It might be two oxygen atoms. That would be considered a molecule because it's still more than one atom stuck together. But it's just an element because it's the same, they're both oxygen. A compound is always a molecule no matter what because it requires two different elements to be stuck together. And the example was water. And then a mixture could be this mixture of three different types of molecules and atoms. And they're not stuck together. You can see them floating around here freely. So an element, we can classify it as a metal, nonmetal, or metalloid. It could be one atom, or it could be more atoms of the same element chemically bonded together, and that's considered a molecule. An example might be a chunk of copper or some aluminum foil. It could be just one atom of neon, or it could be two atoms of hydrogen stuck together, and that would make a molecule. Or it could be 100 atoms of carbon stuck together, as long as it's just the one element and there's no different elements in there. A compound, we classify it by what it's made out of. It looks like there are two or more atoms of different elements chemically bonded together. So it could just be as simple as two hydrogens and one oxygen. Or it could be all of these carbon, oxygen, and hydrogen stuck together like this to make a sugar molecule. Or it could be the dynamite with all of its different elements, as long as there's more than, there's two or more types of elements in that molecule. To name molecules, if the molecule happens to be an element, we just call it by its name. So if it's H2, we would just call it hydrogen. But then if it's a molecule that's a compound, it gets a little more complicated, and there's a very special naming system for that. But we're just going to learn the simple version, the abbreviated version. So you remember that chemical symbols represent an element, specifically one that's an atom. So when you're looking at the periodic table of elements, you would see all of the symbols and realize what that atom would look like based on the numbers that are there. But when we have a chemical formula, that represents a molecule. So we take all of those element symbols, all those chemical symbols, and put them together into one little name. So for example, if we had water, which has two hydrogens and one oxygen, we call it H2O. These little numbers are called subscripts, and they tell you how many atoms there are in the molecule of that element before it. So this is saying there are two hydrogens and one oxygen. We don't ever write the one, so if there's not a number next to one of the chemical symbols, then you just assume that there's one atom of it there. If there weren't one atom, we wouldn't put it in there.